Hi guys, today we're going to talk about the difference between interpolation and extrapolation and how to do both of these. They're almost identical processes. Um, the difference between the word interpolate and extrapolate are those prefixes. So hopefully you've seen this before, it means between, and extra means outside. So the idea is that if we have a data set, interpolating or extrapolating is finding another point that would be in the data set, or what would the data predict. So if we wanted to interpolate, we could say, okay, this looks like a slope of 1/2 throughout this. So an interpolated point would be between the points that already exist, and that would be an interpolated point. If we wanted to extrapolate, we could say, okay, follow this pattern outside the original, and that would be over here. Or another extrapolated point could be 0, 4 or -2, 3. The idea, of course, being that this follows the pattern, that if we, hopefully I can draw straight enough with this. If we follow that pattern, this point being inside is interpolated, and this point being outside is extrapolated. So we'll do two examples. From an exact function, this is one where the data is exact, where it's perfect. A linear function includes the points 0.3 and 71/100ths and 5/10ths, 83/100ths. What will be the y value when x equals 1.2? So the first thing that we should do is find the equation, and we know that it's linear, so we know that we can just do slope, and then if you want to find the y-intercept, but I'm just going to do point slope form because that is one fewer step. So slope formula. Yeah. So we have 6/10ths is the slope, and that means that our equation is y minus 0.71 equals slope times x minus 0.3. So how do we find out what the value is when x equals 1.2? Well, we just substitute in 1.2. Pretty straightforward. We've been doing this, we just haven't called it extrapolation all the time in the past. The reason that this one is extrapolation instead of interpolation is that 1.2 is, as an x-coordinate, is bigger than any of the other x-coordinates. So that's why it's extrapolated. Add 71/100ths to both sides, and we get 1.25 is the y-coordinate. So now we have extrapolated the 1.25 from the data. The different way to do this, if we are given real data that is not always a perfect linear pattern, we are going to have to use a statistical regression. So based on the data set, what would the y-coordinate be if the x-coordinate were 7.0? I have taken that data, I've plotted it over here on Desmos. So here's the data set. You can clearly see that it's not linear. The way in Desmos that you can type in a linear regression is, say, y1 approximates to mx1 plus b. And it will calculate for you, and you can do this with a graphing calculator just as well, what the values are. So that's the 35,218 hundred thousandths. Yeah. So that's our slope. I'll write that down. So 0.35218. That's M. And our y-intercept is 2.0252. So 2.0252 is our y-intercept. So what would be the y-coordinate if the x-coordinate were 7.0? Well, y equals m, x is what we've been asked to substitute in, plus b. You know how to do the rest. I would use a calculator for a 5-digit calculation. And that is how you interpolate. Why is it called interpolation? Because the 7.0 is between two of the x-coordinates. So that is how we interpolate or extrapolate data. Thanks for watching.